Assalamu alaikum. Bonjour à tous. Good morning, everyone. My name is Tariq Ahmed. I am the Regional Program Officer leading the International Renewable Energy Agency, IRENA work in the Middle East and North Africa. It's my great pleasure to be here with you today in this very important event, as well as our panel today about scaling hydrogen production with renewable and electrolysis. So the green hydrogen is increasingly seen as a cornerstone of the energy transition, but challenges remain. Let me borrow some of the words yesterday said by the Minister of Industries and Trade. I think he brought a very important perspective on a reality check, like where we were at, where was the confidence level last year and where we are now. And I think the challenges are quite clear. Like it's how to move forward from pilots to large scale. And at the same time, looking at the cost competitiveness. I think it is one of the cornerstones for the uptake of production of green hydrogen, how we can make it more integrated and globally traded. So to explore this and to discuss this today, we have excellent panel representing technology providers, project developers, and industry leaders. So let me introduce our distinguished panelists today here with us, starting from Magdalene Michael, sales leader for electrolysis business at Accelera by Cummins, bringing market and customer perspective on barrier adoption, drivers, and future technology roadmaps. Next, we have Rick de Biziré, the CEO for ENGIE North Africa and Vice President for EMEA, with extensive experience in scaling renewable energy and hydrogen solution across multiple regions, including lessons from Australia and the MENA region. Also, I would like to introduce Alexander Bonen, the Vice President and Partnership Development Manager at John Cockerill, one of the world-leading electrolyzers manufacturers focusing on scaling manufacturing capacity and developing industrial partnerships worldwide. Welcome. We have also Marcus Speich, Head of Solution Development for Power-to-X at Siemens Energy, driving innovation in large-scale electrolysis system and modular Power-to-X solutions. And last but not least, we have Nadir Azoubi, General Manager for Morocco and Mauritania at Schneider Electric, bringing deep expertise in digital solutions and system integration for energy transition, including complex distributed and islanded systems. So, welcome all. I think today we are coming with the technology, private sector, industries lenses. Let me begin with the first round of questions on vision and strategy before I deep dive into technical, financial, and industrial challenges. Nadir, I'll start with you. So Schneider Electric has a long worked on digitalization and energy services in constrained systems. From your perspective, how can digital automation and system integration enable renewable electrolysis to scale effectively particularly in islanded weaker grids?
Thank you. Thank you for your attendance as well. So today, actually, we should first of all consider hydrogen as an energy element, not as a chemical molecule. So when we consider it as an energy element, so the technology is all developed to help this transformation. And it starts actually with a smart grid, a grid that is enabled to maximize the utilization of these renewable resources wherever it is on the country, increase the integration of this renewable energy, and then convert this renewable energy to a green hydrogen. And then hydrogen could play a good element as flexibility to convert whatever excess energy you have. So I don't need to reduce the speed of my turbines because I have enough electricity in the network. Or I need to disconnect my solar farm because there is no enough capacity in the network. So we need to plug the hydrogen, one as an element to create this flexibility in both on generation side as well on demand side. The second one that will help us to scale the hydrogen, leveraging the technology, is actually the software, the simulators. And this is where we need to look on the all value chain of the hydrogen. And this is where the simulators, the co-simulation, considering energy as well hydrogen, will help on developing this efficiency and this integration. And the key word here is integration. So we should look on the hydrogen, levelized cost of hydrogen is actually linked to the levelized cost of energy. And optimizing the levelized cost of energy actually will help on reducing the cost of hydrogen. So the technology is there to help on improving this optimization. It's help on the more integration. And we understand that, okay, plug in new elements to the grid will create more complexity, but actually it's worthy to have this complexity that can be resolved by the technology.
Thank you very much. I think everyone agrees that the technology plays quite an important role in the uptake of the green hydrogen and synchronizing the different elements that play a role in reducing the costs. So let me move now to Rick. So India has a strong position in North Africa. How do you see the green hydrogen evolving as a strategic export versus domestic solution? And how do you balance that in ENGIE in terms of portfolio decisions?
Thank you. First of all, thank you for having us on the panel. And there, it has been said a couple of times the last day and a half, is that Morocco has a unique position or a unique advantage when we're talking about green hydrogen. It's not only the abundance of the renewable resource that the country has, but also the proximity to potential export markets, especially, of course, Europe, and the talent pipeline to help develop that industry. Now, as ENGIE, if you talk about domestic consumption versus export, of course, in a portfolio approach, the ideal is to have both, because then you can diversify your risks. You don't rely on a single off-taker, which is an advantage on or a benefit on itself. But to be pragmatic, if you don't have an off-taker, you don't have a project. And there, whereas we would look at it from both angles, domestic consumption and export, I think a pragmatic approach would, of course, be to look first at domestic consumption. We've heard in a number of panels yesterday that the need for ammonia and for hydrogen in Morocco is huge on itself. So there you avoid having all the, let's say, transport issues and challenges. So that would definitely be a big part of the preferred solution. And then in the meantime, other solutions can be worked on the export side, is on which product are you going to export? Is it hydrogen? Is it ammonia? Is it by vessels? Is it by pipelines? And we've heard in the panel just before that there's still a bit of work to do to develop those options. But as a company, as a group, we would look at both, and we're quite well positioned because we have since decades a trading arm who was in the past specialized, of course, in gas and electricity, but who has diversified. And so that would help us to find off-takers, because there's not just the physical production and transportation, but there's also the whole commercial and risk management side that has to be looked at as well. And so that would be for us a cornerstone of making this a success.
Thank you very much. So also I wanted you to touch on your past experience in Australia. Do you have any lessons that you think the MENA region could learn from to scale up the hydrogen assets?
So after having commissioned a 3.5 megawatt project in South Africa, we're now working towards the commissioning of a bigger pilot project that we have in Australia, in the Pilbara, which is in the northern, let's say, desert of Western Australia, so quite remote place. It's a 10 megawatt alkaline electrolyzer with powered by 18 megawatts of solar and supported by 8 megawatts of battery. So it's still a modest size, but one of the bigger projects that is under construction as we speak. And there, other than the challenging environment, a bit in the middle of nowhere, of course, we have learned quite a number of lessons, which was one of the reasons we did that project. First of all, good news was we were on the site of one of our clients, Yara, who is a fertilizer producer, and who is the sole off-taker. It's a small volume, of course, so for them it's easy to absorb. So there we had no issues on marketing or having an off-taker for that the product, because it was on site, so that's easy. Now, where other lessons that we learned is that especially at the level of maturity that industry is now, it's extremely important to do your homework on the engineering and to make sure you have a feed that is really robust. And a mistake not to make is, of course, is if you identify a risk, if you want to go fast, the tendency is to increase contingencies, which is not if you have a mature technology and industry, that's quite normal, but if it's new, that's quite risky. And there we learned it's better to de-risk more up front at the project than count on contingencies, but because you can be sure that you will need it. And then it's more like any project that you do is like the choice of your EPC, of your subcontractors. Also, where does the equipment came from? There we used electrolyzers, or we are using electrolyzers from PERC, which is a Chinese provider, which was their first project, in Australia. So meaning their electrolyzers had to be qualified for and go through the homologation for the Australian market, which Australia is a very, let's say, regulated environment with very clear, which is good, but also very strict rules. And so there we faced a number, or the supplier faced a number of delays, which we had to be frank, quite some support from the government, because as it was the first of its kind in the country, once those electrolyzers are qualified or certified rather to be used there, of course all the next projects will benefit from that. So, but quite a number of lessons learned, but very proud to have something on the ground.
Thank you very much. I think we all agree that there is, like every region has its own context and its own challenges, but always there is a common things that we always can learn from here and there. So now let me dive deeper to the technical scalability, business models, and value chains. I will start with Marcos. So Siemens Energy has been involved in multiple Power-to-X projects globally. What lessons are you applying to modularity and standardization in electrolysis systems?
Thanks for the question, Tariq, and thanks for inviting us here to this panel. The short answer would be yes, yes. So there are significant lessons learned, and we need automized fabrication. But let me give you a bit of background why and how. So fortunately, we can already benefit from the experience of more than 150 megawatt of units in operation. In addition, we have more than 750 megawatt under construction in different phases. So based on this experience, we have derived a significant learning curve already, and I would differentiate in three different areas here. One is manufacturing, second is system design, and the third is the overall hydrogen plant design. So in manufacturing, we have established a new facility in Berlin, end of 2023, where we are now, based on the learnings from all our projects and the measurements we have taken, we could significantly improve the quality of the whole manufacturing process and get the right stability for these large-scale products. On the electrolyzer system design, and with system I mean everything from transformer through rectifier and array. On the system design, we have increased modularization and prefabrication in order to reduce the installation efforts at site and also installation time at site. This will benefit the overall total installed cost of the project and finally the levelized cost of hydrogen. And last but not least, we have recently launched our second generation of reference plant, which is in the 100 megawatt scale, where we have a fully pre-designed turnkey hydrogen plant, which enables us to perform very fast feed execution and also ensure a very robust and stable execution then during the implementation. I would say these are the three important pillars where we have these improvements, these learnings, where the industry can benefit from.
Thank you very much. I think that's quite inspiring. Like if I ask you more about, like over the last few years, are you seeing any demand for factory built or plug and play units yet? So are you seeing demand for factory built or plug and play units?
Yes, definitely. I mean, these large-scale projects, they need a high degree of standardization and automation. Our total backlog is now almost 1 gigawatt, so in order to cope with that, we need this standardized fabrication in place. And that's happening around the globe, not only with Siemens Energy, but also with other manufacturers.
Thank you. And that takes me to the next question to Magdalene. So looking at the sales angle, what are the most common hesitations you encounter from buyers and investors when it comes to electrolysis systems, and how do you address their concerns and on cost and risks?
Yeah, thank you, Tariq. First of all, thanks. Inspired being part of this panel, having different OEMs on the same panel. It's always unique and different. I guess just a quick intro about Accelera by Cummins. So Accelera by Cummins is the fifth and newest business unit for Cummins Power Generation, or Power Cummins Inc. So we are an American company, 106 years in different business related to manufacturing, engines, and power generation, and other core business. Just to your question, Tariq, related to the key challenges, I guess the key challenge for the market is the commercial viability as of today. And this goes to a discussion related to the leverage cost of hydrogen. Just a high-level analysis, 60% of leverage cost of hydrogen comes out of the renewable tariffs and 35% on the capex for the full plant of total installed cost. And this drives the discussion towards the capex piece, which can be misleading at a point of time. the right judgment for electrolysis from a sales angle, you need to check, of course, CapEx, one of the angles, but need to check the efficiency. Also, you need to look to the dynamic response of the units. You need to look into the turn-down ratio, which means how much less load you can use on the unit to give you the hydrogen production at the end. And also, because this is a new market, electrolysis business, you need to know that not all the OEMs have the same battery limits or the same scope of supply. I may have additional value proposition that will optimize your total installed cost. This doesn't mean that this is right or wrong. It means that we need to dive into the engineering understanding of each product portfolio you have into the evaluation. So the right evaluation, not only CapEx, it's CapEx, OpEx, efficiency, total installed cost. And I guess we learned a lot, and we keep feeding our product and development team from, we have more than 400, 500 megawatts under execution. And the biggest operational unit, 20 megawatts since 2021. Now we have commissioned an in-operation unit, 35 megawatt in North America as well. So a lot of lesson learned once you get into operation, and the number of hours and the issues and lesson learned. This is really important at the first stage of this emerging market of green hydrogen. So yeah.
Thank you very much, Magdalene. I think that takes me to the manufacturers and how they see things. So now I move to Alex. So John Cockrell is among the largest electrolyzer manufacturers worldwide. From your point of view in partnerships, what are the main bottlenecks in scaling manufacturing, supply chain, certification, or financing?
Thank you very much for the invitation, first of all. I'm going to answer your question first by saying that John Cockrell Hydrogen has and is busy expanding its production capacity worldwide. We have 2 mother plants, if I can name them that way, one in Europe, one in China. And I'll come back to that because it's very important to understand the rest of the question. Those 2 mother plants are key for delivering the first projects. But on top of that, we, as the market knows by now very well, we have signed a JV in India with a partner, with AM Green, and we can name it as well, for to build another 1 gigawatt plant in India and to deliver basically the 1.2 gigawatt sale we achieved last year. On top of that, we also have a factory which is under construction in the United States. So we are talking about 4 factories of 1 gigawatt capacity. That network is really key to address the market. Now, in terms of bottlenecks, this being said, if you look at the supply chain is not the main bottleneck. Why? Because thanks to that network of plants, thanks to the framework agreements we have with different suppliers, thanks to the supply chain industry, which is relatively well developed, we can play on the local level, regional level, and global level, and make sure that we're going to secure the supply of our electrolyzers to our customers. And that's very important for them. So that's not the bottleneck. Now, if we talk about standardization is seen at John Cockrell Hydrogen not as a bottleneck, but rather a required effort to rationalize the products, to always look for cost optimization by working out standards, by working out a way to repeat things to make them more cost effective. And again, we all know that today we have to make the hydrogen molecule cheaper than what it is. And if we want to reach that pivot point, so we can really turn the market into a virtuous circle. So standardization is not a bottleneck, it's a must. And by having also production base in the United States, in India, in China, in Europe, and by combining all the lessons learned we got from those plants and this production, we learned a lot about standardization, we learned a lot about norms, and we can deliver everywhere in the world. So I'm going to end my answer by, of course, the bottleneck, which is definitely financing. And behind financing, what do you have? It's basically offtake. It's guaranteed offtake. Because a guaranteed offtake for any manufacturer means that you have something bankable, if I may use that word, in hands. And then you can go and see the banks, and you can project finance your activities and operations. So definitely the financing is the key bottleneck, and to secure the financing, we need to have secured offtake. So once again, we need to have a market, we need to have offtakes, we need to have commitments, because we don't want banks to lose confidence into the hydrogen industry. And we need to keep this confidence into the projects, and for that, it's a joint effort between all the parties.
Thank you very much. I think that brings me to where yesterday the discussion that brought by His Excellency the Minister of Industries, when he mentioned about the cost competitiveness, and to create the demand or to have the offtake to pick up the market will need to be very much cost competitive. And that takes me back to you, Magdalene, looking forward for solutions. We want to, like we discuss about challenges, but we want to see also solutions, and down the road in the next 2 or 3 years, what we should do or what we can expect. So looking ahead 3 to 5 years, which electrolyzer advancement or economies of scale do you expect will drive the biggest cost reductions?
Yeah, thank you, Tarek, for the question. I guess we are thinking on a short term for until 2030 or 32, and on a longer term. So we have already invested ahead of demand in manufacturing facilities globally, which can reach to 1 or 2 gigawatt per year. So this is already infrastructure that it's currently available. We have a couple of facilities, one in North America and Fridley, the other is in Mississauga, Canada, and another 2 in Europe, one in Belgium, Oval, and the other one in Guadalajara, Spain. So manufacturing and scalability is there, one of the pillars. The second piece is the standardization. As Alex was mentioning, we have already implemented the standard product for our 5 megawatt modular solution, and we are working on optimization for the cost, increasing the efficiency. So by default, this will impact your leverage cost of hydrogen positively, or you will have a better leverage cost of hydrogen. So this is the key pillar, and from a longer term perspective, we are looking into giga-scale kind of XL solution, as we call it, X-large scale solution, which will be triggered or dealt with in a different way. So for a short term, we have our 200 megawatt plant level with an optimized leverage cost of hydrogen. I guess we will officially announce it in October, end of October timeframe. But from a long-term perspective, I guess it's a game changer when you are talking about giga-scale kind of deployments. So this is actually in the product development. So this is our phased approach related to scalability, optimization of the cost for the current product, and a long-term plan for the future product. So.
Thank you. Let me pick up with the optimization part that you mentioned, because operations and maintenance. So Marcos, I wanted you to tell us more about the role of technology. How can large electrolysis systems be optimized for flexible operations with variable renewables? How do you see the role of technology, AI, advanced controls, digital twins in improving efficiency?
Thank you, Tarek. So as a first step, at the very early stage of the project, we need to design the whole configuration and value chain, not only to cope with the fluctuating renewables and the volatility, but also to optimize it already for the lowest levelized cost of the product, be it hydrogen or derivatives. In order to do so, typically we build up a simulation model based on all the different elements, using the constraints and characteristics of all systems, but also feeding in the wind profile, the solar profile, and run a optimization which can go over 12, 20 years, and as a result, derive a configuration which can cope with the dynamics, but also has an optimum result in terms of levelized cost. So that would be then the input even for a pre-feed stage, let's say, yeah, to look at the timing of this exercise. So once this is done, the plant is capable and designed for the competitive production. And after that, you need to make sure that all the elements in reality can also follow this demand, which was modeled and simulated. So in extreme environments, especially with a fluctuating wind profile and huge demand on start-stop operation, we have our PEM electrolyzer system, which is capable to ramp up and ramp down very fast, talking about 10% per second. This we use then, of course, also to minimize the OPEX and the life cycle cost of the project. So the result could be a PEM solution, but it could also be a mix of alkaline and PEM in one project based on these simulations. So one result is technology selection. Another result is the sizing of all the different systems and components. And the third result is how to operate the plant and during real life at a later stage, and that where then the control systems come into play. And for that we have developed a dispatch optimizer and microgrid controllers who ensure the stability of the plant, but also ensure at every point of operation the optimum economics, taking into account also weather forecast or forecast on electricity cost, and that is the AI element which is built into this control system, predictive operational dispatch.
Thank you very much. And also around the same lines, I want to come back to you, Alex, on industrial ecosystems. So industrial ecosystems will play a major role in hydrogen competitiveness. What role do you see for regional clusters, joint ventures and supply chain hubs in anchoring the Middle East and North Africa, positioning in global markets?
Well, in terms of competitiveness, if you allow me, I would prefer to talk about regional competitiveness rather than global competitiveness. Reason why this subtleties is because at Junkerville Hydrogen we do not consider the sale of an electrolyzer as a one-off sale. It's not like you have a product out of the shelf and then you ship it somewhere, you realize a one-off sale, and that's it. What we want to achieve is really to accompany the customer, not only in delivering the electrolyzer, installing the electrolyzer, commissioning the electrolyzer, ramping up the production of the electrolyzer, but then we know that it's going to be about really delivering the maintenance services that will go with it, because we'll have to deliver the performances that we would have advertised to the customer, and we want to deliver that. We need to accompany, so as I said, the end customer, and for that we have a maintenance service program to go with it, because we know that at a certain moment the electrolyzer will need to be replaced, and when you realize that you're going to have a developer that will have to manage basically a park of 200, 400, 600, 1,000 electrolyzers, at a certain moment you need to be with the right partner. And knowing as well that an electrolyzer is a big boy of 50 tons of steel and other components, you realize the challenge. Meaning that what we have to develop in terms of competitiveness, to come back to your question, we need to develop the right ecosystem to the regional market that we are addressing. We want to have the right vendors. We want to have the right maintenance services. Reason why John Cockerill Hydrogen here in Morocco can count on its existing operations, where we have 300 people already active delivering services on the Moroccan industry marketplace. But, and that's why I prefer to talk about regional competitiveness, because if the right ecosystem is set up, then basically the region, the country can resist against the temptation to work only with imports. And especially if you want to create local value as well into the country, you need to localize your operation, your production, your maintenance services, be close to your customers, and make sure that the entire value chain from the university, the R&D centers, the developers, the ECPs companies, and the UMs, that we are joining forces to make all that viable and cost competitive against, I would say, just imports. A reason why I prefer to talk about regional competitiveness rather than global competitiveness.
Sure, thank you very much, Alex. Nadir, back to you on research and development. If we want to accelerate cost reductions and efficiency, which research and development or service innovation areas should we prioritize? System integration, digital monitoring, operational and maintenance optimization?
Sure.
Tell us.
So before we talk about technology, actually there is an element about the market and the business model. I was just looking a couple of days ago on the history of our photovoltaic business globally. And when we look on the cost of the solar cell in 1977, it was $78. And today is less than 20 cents. So there is a big scale will come from the business model itself that will help the technology as well to develop and to follow and solve all the challenges that we face on we scaling up. When it comes to technology, as my colleague Mark said, we start with the design and engineering. And this is where we need to develop more tools to help us to look on the end-to-end solutions in much more optimized way. We need to develop our digital twins to help us to monetize, these investment in more efficient way. And I think we need more power process integrated simulators. As I said in the beginning, that hydrogen also is an power element, is an energy carrier. So we need to look also on this element as an energy topic. So this is when it comes at the design and engineering phase. On the, let's say, management side, we need to develop more tools like what we have, EcoStruxure automation expert to help on optimizing the all design, engineering, and deployment of these solutions. And then the last element will be during the life cycle and operational side, like the EcoStruxure as the advisors to develop more the, let's say, digitization part and monetization of these assets, helping on developing a more predictive approach to ensure the maximization of the utilization of this operation. And the fourth element will be more on the forecasting side in terms of energy as well hydrogen production. To ensure that we really achieve the minimum levelized cost of energy that will help us to achieve the minimum levelized cost of hydrogen.
Thank you very much, Nadir. Now let me come back to Rick with very last question before we open for questions. So Rick, in closing, I would like you to share with us one sentence reflecting on how do you see by 2030, what would success in scaling hydrogen look like from your perspective?
It's, I think that's a $1 million question for the whole sector. I think if there's one thing I would say by 2030 that we have real industrial size, like hundreds of megawatts electrolyzers being powered by renewable energy working.
Thank you. I would also go back to everyone with the same questions. By 2030, how do you see
I guess I share a similar perspective to Rick. So a couple of hundreds megawatt in operation is a great start to learn from and understand as well from an operational perspective, what is the lesson learned. There may be a lot of things look perfect on paper, but once you operate in a mega scale, you learn a lot of lesson learned to feed the optimization for the unit before we think of giga scale. I guess I would be happy to see half giga operating and learning from before targeting the giga scale afterwards. So yeah, that's my perspective.
Alex?
The challenge is, as we know, the offtake, building the ecosystem, being more cost competitive. And I'm a strong believer of partnerships. I do believe that there is still a lot of room for everyone. And then all the players of that ecosystem should rather join forces at the moment, and definitely not, we'll fight later on. But at the moment, we need to build this market, we need to join forces and cooperate.
Marcus?
Yeah, I would say two challenges. One on the regulatory side. I think we need to get clarity, stability, and some leeway on the regulations, especially for the first movers. That would something I would wish from the governments to work on that. And that is more the regulatory and offtake side, which is affected. And on the technology side, I think we have to now move also into off-grid applications, looking at regions with abundant renewable energy. Sometimes they're weak grids, so there need to be off-grid solutions for integrated projects. And we have done pilots, but not large scale yet, and that is the next step we have to take on the technology side, which we are ready to support.
Thank you. Nadir?
Well, the future is electrification, so I hope that we have a big step in 2030 toward more electrification, where hydrogen will be an important element to decarbonize the heavy industries and hard-to-abate industries like steel, aluminium, smelters. And then all the technology will support. So I think regulation is a key point, the carbon tax and pushing these heavy industries to move ahead toward more decarbonization that will help us to scale up this business.
Thank you very much, everyone. Now, the turn of the floor. If there is any questions, burning questions to our speakers.
Thank you very much to everyone for this panel. Very, very instructive. My name is John. I'm representing this French company, GTT. We are developing designs for liquid ammonia carrier, liquid hydrogen carrier, apart from our core business, which is LNG. So I wanted to ask you, do you have any insights on when you compare transporting liquid ammonia and liquid hydrogen from Morocco to Northern Europe, for example, as a case? Which one do you see as the winning horse? Do you see both these options going beyond 2030 and existing? Or do you think that ammonia will be sent as liquid ammonia in ships only, and we won't see liquid hydrogen? Do you have any insights in this sense? Thank you.
Who wants to take this one?
I could make a statement on that from our perspective, what we see in the market. So I think liquid hydrogen as a carrier is still at least a decade away from today's projects. That's our opinion. So we focus more on projects where either the gaseous hydrogen can be transported through pipelines, ammonia can be transported either directly or in form of its further derivatives or products like fertilizer. For that, we need still, I think, additional infrastructure still on the offtake side for the crackers. So that's a bit bottleneck on the ammonia side. I would bring also methanol into the game because methanol is an easy to handle energy carrier which can serve as a basis for maritime transport, but also be converted into kerosene via the ESAF process, and then serve also the demand and the quota we have to fulfill for the aviation industry. So that's a bit the priorities we see. So we see even a strong demand right now, and hopefully supported by a positive IMO decision in 2 weeks from now. On the methanol side, ammonia, we also see a strong development there, also for shipping. But liquid hydrogen, I think, will still be a couple of years away.
Yeah, I believe liquid hydrogen is a question mark a little bit because of the scalability of the liquid hydrogen, specifically on the storage. I guess you need to store liquid hydrogen at negative 273 Kelvin, right? So the challenging of the storage of the liquid hydrogen remain as a question mark. But I guess it's according to the application. So for example, power generation and marine sector, maybe going towards the e-methanol. This is what we know now. Things can change, of course. Green ammonia is still a valid one, but the key problem is the commercial viability of green ammonia has to go with scalability beyond the giga scale, and the offtake agreements on a long term. So I guess it depends. ESAF can be a good business case, but I believe liquid hydrogen Raymond still need a lot of studies to understand if it's the right business model or not. Yeah.
Any other questions? I think with that, I would close. So thank you all for your really great insights. I think what we have here today is that hydrogen or scaling hydrogen is not only about electrolyzers technology. It's about synchronizing renewable deployment in industrial manufacturing, digital optimization, and supportive policies. The opportunity is massive, but success depends on aligning industry, finance, and governments. So please join me with a round of applause to our speakers. And we are really happy to have them here. Thank you all.